What's up everybody, this is Ryan here. So the very first tutorial I ever made, at least on the topic of Android on YouTube, was for the RecyclerView way back in 2016. Now back then there was a couple things about it which made it kind of tricky to set up for people, so that's kind of what inspired me to try and make a video on it. Well, I'll be basically teaching the same API today, but luckily there are a couple improvements to it which will allow us to do a couple of things. So for starters, the RecyclerView we'll be building today is going to be, the adapter at least, is going to be decoupled from the fragment, which is kind of important. It's going to handle click events super easily, as we'll see. We don't have to have like 7 different interfaces going on. We'll actually handle click events just by using a mutable LiveData object. And then, finally, our RecyclerView that we're going to build here, we're going to use a particular class called ListAdapter, which is like kind of a specialized adapter. And what it's going to allow us to do is it'll basically remove our need to have to call functions like notify dataset changed, notify item range changed, notify item inserted. There's basically, if you're not familiar, in earlier RecyclerView API implementations, you had to call all these different methods on the adapter based on what happened in your RecyclerView. And it could actually get pretty annoying and complicated. So what we'll do is we'll basically set up a bit of a boilerplate class called a DiffUtil and .item callback, I believe it's called. We'll see it in a minute. But basically what this thing's going to allow us to do is it'll basically remove the need to call all those different functions, and instead we'll just be calling one function, and then we'll let this DiffUtil, our ListAdapter, and a couple other things which we'll go into in the video handle all of those updates for us. So it's going to be way simpler, and best of all, this particular implementation is going to figure out or calculate the changes that need to be made to the RecyclerView on a background thread. So no more blocking the main thread. Now, since this is tutorial number 8, and I've already covered a whole bunch of topics such as writing a view model, writing a fragment, Model-View-ViewModel architecture in general, constraint layout, all those different things. What we're going to do is there's certain parts of this tutorial that we're not going to go into much detail in. However, I will show you all of the different steps necessary to actually set up the RecyclerView. What we won't be doing is we won't code out the whole fragment which displays the RecyclerView, and for the layouts that we'll be using in the RecyclerView, I'll show them to you and mention anything that's important, but we're not going to build them on camera. If you want to learn how to do that, I have a whole tutorial on constraint layout which will help you figure that kind of thing out. Now, before we proceed, if you want to actually follow along with the tutorial in real time, you're going to want to either clone or download the repository. Link in the description box down below. Now, this could end up being a fairly long video, so I'll make sure I include timestamps in the description box down below if you want a detailed idea of the topics and when we cover them in this video. The first file that we'll be looking at is called Fragment Note List. So this is the layout which actually contains the RecyclerView. So as I say, I'm not going to go into too much detail here, but here's a preview of the layout. You can't actually see the RecyclerView here, but this is basically what it would look like if there are no items in the RecyclerView. So I'm just going to open up the text editor here, and we'll just look at this particular XML view. So the first thing I want to bring your attention to is we have this color transparent black background. So what I wanted to do here is, instead of just setting the alpha of which alpha means opacity or the degree to which something is transparent, instead of just setting that directly on the RecyclerView and kind of blurring things, I just wanted to make sure that the background of the RecyclerView basically made the elements in it a little more viewable, a little more visible. But you could still see the space background behind it. So the way that I achieve that effect is I basically just set the background of the RecyclerView to color transparent black. And if I open up colors.xml, that's basically just the color black with a hex value of 52 for the opacity. So in the sense, this is like setting the alpha, except only for the background image. So the second thing to point out here is that I've specified a linear layout manager in the XML. So I used to do this in the Java or Kotlin code, but I actually find it simpler to just do it declaratively in the XML in this particular case. And notice that I'm using a linear layout manager. Depending on what kind of layout manager you use, that will kind of dictate how your RecyclerView behaves and how it kind of arranges the different items within it. Final thing to note here is that I've specified the default visibility of this particular view to be invisible. And as I explained before, that's because when there's no items retrieved from the database, then I basically just want the recycler view to be entirely invisible. Alright, so the next file we'll be looking at is itemNote.xml. So again, I'm just going to talk about some general things, but we're not going to actually code this particular view out. So the first thing I wanted to mention is that both the primary graphic and the little icon down here are vector drawable resources. So I have a tutorial on that, and you can go and watch video number 3 in this series if you're curious about how to set these up. But just to explain really quickly how they work, basically they will scale to pretty much any screen size within reason, and they won't lose quality or anything like that. And the best part about that is that all of that happens through one single drawable resource, so we don't need to specify resources for different screen sizes with vector drawables. Now, looking at some of the more specific details here, I just want you to note a couple of things. So the way that I arrived at the general dimensions, margins, padding, and those sorts of things is I basically went to the Material Design Guidelines website and pretty much copied what they did. Now, I do align things a little bit differently than what they suggest, and so what I recommend is if you want to figure out how to align these things appropriately, go check out what their guidelines are, start from there, and then tweak things a little bit in order to get the effect that you prefer. So there's one last thing that I want to mention about this file. If I scroll down to our primary text view here, I just want you to notice that I've specified single line equal to true, and then I've specified ellipsize.end. So what exactly is ellipsize.end? This is kind of important if the text in your recycler view may end up being longer than the screen. What ellipsize means is it's just whenever the text kind of cuts off, it's just going to add a ... or ellipses as they're known. And that's just going to make our recycler view look a little bit prettier in the event that the text is too long for the screen. Okay, so we will end up coding the adapter by hand, but there's one little boilerplate class here which is necessary to write before our ListAdapter. And basically what it is it's a DiffUtil.item callback object. So don't let all these scary names confuse you. All this little class here does is it basically takes in some kind of data model. So let me open up Note. So Note is basically the conceptual data which each item in our recycler view will represent. So whatever data model you're trying to display, so it could be like a user, it could be an exercise, it could be a note, for example, you're basically going to want to create a DiffUtil .item callback object, which basically includes that particular data model as a generic type here. So what is that going to do? All it's going to do is it's going to allow you to have some way, if your data models have a unique identifier, which they probably should, of figuring out if an item at a given position has changed or not. So if that's not super clear, I think once I dive into the source code of the ListAdapter, you'll probably understand how it kind of works. All you need to understand here is that if you want to set this thing up properly, whatever data model you have needs to have some kind of unique identifier. In this case, I've chosen the creation date of when the user basically creates the new node to be its unique identifier. And then at some point, as we'll see later on, some internal class is basically going to use our callback object here in order to determine what items in the new list are different from the old list type of thing. Okay, so in a moment we're actually going to basically delete this entire class and then rebuild it. This is our adapter for our recycler view. But before we do that, I want to take you through a bit of the source code of the ListAdapter class. So as we'll see in a moment, this thing is actually a subclass of RecyclerView.Adapter, but it's integrated with a note, or not a note in particular, but some kind of DiffUtil.item callback. And so as we'll see in a moment, that's why we needed to create that particular thing first. And what I'd like to do is I'll take you through some of the internals of this class so that you can actually understand what's going on here. So what I'm going to do now is I'm going to hit Control-N, and then I'm going to delete that because that's totally in my way. And what I'm going to type is ListAdapter. Now, up in this checkbox here, you can see we have this include non-project items. So I'm going to click that, and I want you to notice that all of a sudden we have a whole bunch of different options that have popped up. So the one we're actually going to look at from the library, the RecyclerView library, is ListAdapter here. Okay, so what's going on here? So all of a sudden we're in Java land because this is a Java class, but what I'll do is I'll just kind of explain what's going on here. So the first thing I want to point out here is that this ListAdapter class, as I said before, extends RecyclerView.Adapter, so it's capable of behaving as a RecyclerView.Adapter. Now, the most important thing you need to understand with this particular class is that it has this async list differ member here called mDiffer. Now, there's two constructors we can use to create one of these list adapters, and the one we use accepts our DiffUtil.item callback object. That's important because it's going to basically create a new mDiffer member partly out of the callback that we supply. So in a moment, we'll actually see how this diff callback actually saves us time and effort, but there's a couple other things in this class that I wanted to point out. So as I mentioned before, how we used to have to deal with our RecyclerView adapter when the underlying data set that it's looking at changed is we had to call all these different functions like notify item inserted, notify item range removed, and all kinds of things like that. So this was really annoying and caused a lot of problems for different developers. And also the thing about using notify dataset changed is that it was a very inefficient function. So anyways, what we're going to do is, as we'll see in a moment, this list adapter, when we want to actually update the contents of the adapter, all we have to do is we just call this submitList function down here, and we provide a list which contains whatever data model that we're working with. So what I want to point out here is that when this function is called, it's going to call the same function on our mDiffer object, and then it's going to pass the list in. What we'll do next is we'll look at the async list differ source, and then we'll kind of see what goes on inside of there. Okay, so there's one more source class that we're going to look at and understand. I'm just trying to give you an idea of how this thing works under the hood. So I'm going to hit Control-N twice, and then we're going to look up async list differ here. So this is a pretty complicated class. All I want you to understand here is that this async list differ class has a main thread executor object here. And what that's going to do is it's going to allow it to call back to the main thread, and then we'll see it also is capable of doing work on a background thread. This is important because if you're making a huge update to a recycler view, that could potentially be a long-running operation. So this is part of the magic of using this particular setup with ListAdapter and async list differ, is that it's going to allow us to figure these updates out on the background thread appropriately. And you don't actually even need to know what's going on here. I'm basically just taking you through the source code as an extra step. So we have our main thread executor, and the only other thing I want to show you in this particular object here is I want to scroll down to the submitList function. And just remember, submitList is what we're calling on our list adapter, and then that's going to get called on our mDiffer member. Okay, so if we go down to submitList here, we'll see the first function here accepts a list, and then the next one is basically going to call it's going to call an overloaded version of this function down here, submitList, and this is actually where the magic happens. Now, the thing I just want to point out to you is if I scroll down, I know this is a really horrendously huge function here. But if I scroll down here, just understand at a certain point, we're going to say mconfig. Don't worry about what that is. It's basically going to get a background thread executor, and this is how it's going to actually calculate the difference between the old list and the new list and do that work on the background thread for us. Now, importantly, one little detail, if you're wondering how it actually gets a hold of the NoteDiffutil callback that we created, understand that it's going to get a hook to that class through this mconfig object here, which we actually created up in the list adapter somewhere here. As we have a little builder class there. And so it's going to get a hook to the DiffUtil callback that you wrote, And then from there, it's going to ask it to compare the different items. And that's ultimately why we needed to create our DiffUtil callback. Once all of this is done, it's going to dispatch this result to the main thread. Okay, so now that we've had a look at the internals of the ListAdapter class that we'll be working with, and hopefully that was interesting to you. If you enjoyed going through the source code, then please let me know down in the description box below, and I'll try and do that kind of thing in the future. So anyways, at this point we're going to rebuild our NoteListAdapter class, and what we're going to do is just go ahead and open it up, and we're just going to select everything in here except the import statement at the top, and we're just going to delete it like so. Alright, so you might be wondering at this point, Ryan, how exactly is that making things easier for us? That seems kind of complicated. Well, the good news is that the complexity in the classes that we just went through is going to result in less complexity in the classes that we're going to be writing momentarily. So in order to actually write out our adapters constructor, we need to create our ViewHolder object first. So we'll start with that. So this class is going to be called class NoteViewHolder. It's going to have one property here, which is going to be called root, and it's going to be of type view, and we'll see what happens in a moment with that. And then it's going to have, it's going to extend RecyclerView, oops, that's not what I wanted, RecyclerView.ViewHolder, like so. And what we'll do is it's going to complain because it's expecting this thing to accept a view. So that's where we'll pass in this root view object here. And so that will become the item view property of the view holder. And just take note of that because we'll use it later on. So the purpose of this class is it's basically kind of like a bridge between our note data model or whatever data model you'll be using and our item note layout. So it's kind of like a virtual representation of the layout. And so in our particular layout, we really only need to represent the, in this case, the creation date and also the contents of the note in the actual layout. So it follows that we just need to include two different references here. So the first one is going to be called var content for the contents of the note. It's going to be a text view, and it's going to equal root.lbl message. So again, don't forget root is referring to this thing here. And then I'm just going to select at the, click at the end of here, and I'm going to hit Control D. And this next one is also a text view. It's going to be called date, and it's going to point to root.lbl date and time. So just a really quick aside here about the note view holder. If you're wondering where the name RecyclerView actually comes from or what it refers to, it basically means that as the user is scrolling through their list of items in the RecyclerView, the RecyclerView.Adapter is going to recycle the ViewHolder objects instead of creating a ViewHolder object for every item in the RecyclerView. So minor point here, but it's just kind of important to understand that that's where we actually get the efficiency of the RecyclerView and why it's called as such. Okay, so now that we've got our ViewHolder set up, we can actually write the class declaration for our adapter. So what that's going to look like is we're going to type class NoteListAdapter. I'm going to leave the constructor empty for a moment, but we will put something in there. And then this class here is going to extend ListAdapter, and it's going to basically accept a couple of different types here. So what we need to do here is, if you want to figure out what what a given class needs in Android Studio for constructors or types like this, generic types, we can hit Control P, and it's actually going to kind of give us some kind of idea. So in the case of T, this actually refers to our data model. So in this case, I'm going to type note. And then for the second one, we have some kind of view holder object, and that's going to end up being our note view holder, and that's why we needed to create that thing first. So in here, I'm going to type NoteListAdapter.noteViewHolder. Now it's still complaining because, as you can see here, we're referring to something which is supposed to be within NoteListAdapter. So I'm just going to throw down some curly brackets here, and then we're going to move that NoteViewHolder object into the adapter like so. So there's obviously a couple things we need to fix here. So go ahead and click on the red highlighted NoteListAdapter here. And what I'm going to do is I'm going to hit Alt-Enter, And then we can click on Implement Members or hit Enter, and make sure you select both of these and then hit OK. And so these are the functions that you basically need to implement in order for this thing to work properly. Notice how there's a couple fewer functions than compared to a normal RecyclerView adapter, and that's because some of those functions are actually handled inside this ListAdapter class. So we'll get to implementing those in a moment. There's another thing we need to deal with. So our ListAdapter is showing up red, and if I click inside the parentheses here and hit Control P, it's going to say that it's expecting some kind of DiffUtil.item callback object. So all we need to do in this case is I'm just going to type NoteDiffUtil callback, and then we'll add brackets at the end of it, and that's going to actually create an instance of the NoteDiffUtil callback object. So in my older tutorials, the way that I handled click events was basically to either nest the adapter inside of the fragment or activity, which it was supposed to call back to, or by holding reference to whatever class it was trying to call back to as an interface. So we're going to do neither of those and take an option which is a little bit more decoupled and I think a little bit safer. So what we're going to do instead is we're going to use a mutable LiveData object to call back to the fragment. So what we'll do is we're going to type val event, and it's going to be of type mutable LiveData, and the type is going to be a sealed class, which is NoteListEvent. So if you're wondering exactly what this is and how mutable LiveData work, go and check out the particular part of the tutorial where I actually discuss these topics. Just really quickly, NoteListEvent is a sealed class which represents different events which can occur in the front end. And mutable LiveData is basically something that can be observed, but this mutable word means that we can change its value, and the value is what's basically wrapped up here, whenever we want to. And when we change it, if our fragment, for example, happens to be listening to this mutable LiveData object, then it will know when a particular event happens and what the details are. So in order to complete this, we're just going to have to actually create this thing. So we'll say equals mutable LiveData, and we'll give it our constructor. So the first function that we'll implement is onCreateViewHolder. So beyond what the name implies here, basically what this particular function does is this is where we actually inflate the layout which our RecyclerView will use. So what we're going to do is we're just going to mess around a little bit here. So we're going to say val inflater equals LayoutInflater dot from, and so we're going to use this parent object here, which is a view group. So from parent dot context, and that's going to get a hold of a context object. Now this is really important. Whenever you're messing with context, you need to be careful about memory leaks, and there's a particular step we're going to go over in the fragment which is going to prevent this particular adapter from leaking. This is kind of a problem with adapters, is we have this ugly situation where it's a class that needs to have access to things like layout inflators and the view hierarchy, but it might be somewhat detached from the life cycle of, say, the fragment. So like I say, we'll see a specific step we need to follow in the fragment in order to make sure that this isn't an issue for memory leaks. Anyways, once we have our layout inflator object, what we'll do next is we're going to type return NoteViewHolder, like so. And inside of this NoteViewHolder object, which expects a root view, this is where we'll actually do our inflation. So we're going to say inflater.inflate. And so in here, we're going to provide the actual item note layout, which is the layout of each item in the RecyclerView, r.layout.itemNote. And then we're going to give it parent, which was passed in up here. And then we're also going to provide, we're going to say false for attachToRoot. Okay, so some of you might be wondering, what exactly is this attachToRoot and why is it false? If we leave it false, does that mean that our views, our view holders, are going to be magically floating around the user interface and unbound to anything? The reason why we're passing false in here is because we do not actually, we don't write the code to attach this particular view to the view hierarchy. So basically what that means is that it's going to inflate this r.layout.itemNote view. It's going to get some layout parameters from this parent object, and if I hit Control P, notice this thing is called root. And so just understand that everything's going to work fine. When would you want to use attachToRoot true? That would be if you are writing some particular class which is responsible for attaching a view to the hierarchy. In this case, this occurs internally, so we can just leave it false and we don't have to worry about it. Alright, so what we're going to do next is we're going to write out our onBindViewHolder function. So the first thing we'll do is we want to basically get a hold of the note item at a given position, and position is provided here. So what we'll do is we'll call getItem, which is a function from the adapter, and then we'll pass in position. Then we're going to say .let. So basically what's going to happen here is we're saying, okay, get this thing, and then in this block of code, as soon as you get that thing, I want to do something with it. So in this case, just to make things a little bit more legible, instead of using the it reference, which is a little bit confusing to some people, I'm just going to type note. So we're going to give a name to the thing that is returned by this function, and then it kind of pops up in here. Then we need to add an arrow thingy here. So what we're actually going to do is once we get our note object here, we need to bind it to the ViewHolder object, which was passed in. So what we're going to do is we're going to type holder.content for the first one. And remember, that's just what we defined down here. Holder.content.text, because it's a text view, equals note.contents. I'm going to hit Control D, and for this one we're going to say holder.date.text equals note.creationDate. And then what we'll do after that is we're going to add a click listener to the entire sort of root layout of the ViewHolder object. So we're going to say holder.itemView.setOnClickListener, and we're just going to use a lambda in this case again. So what's going to happen is when this onClick listener is fired, whatever we write in here is going to be executed. And so what we're going to do in that case is we're going to publish an event to anything which is listening. And the way we're going to do that is we're going to use our event mutable live data property up here. So what we want to do there is we're going to type event.value to get the value of the mutable live data object. Then we're going to set that value to a particular kind of event. In this case, the event will be NoteListEvent.onNoteItemClick. And then that thing requires a position, which will be the position that is passed in onBindViewHolder. Now, I'm sure some of you are wondering what this class looks like, so I'll pull it up really quickly. So NoteListEvent. And just understand it has a couple different events, basically any event which can occur in the note list feature of the application. And the one we used is onNoteItemClick. And as you can see here, it accepts a position as a property, which is what we pass into it. So that's actually it for our adapter object. So what we'll do to finish this video off is I'll take you through the fragment, which holds the RecyclerView and interacts with the adapter. Now, we're not going to code everything out because that would take a needlessly long time, and I've already explained how to code up fragments in a previous video. But what I will do is take you through specific steps which you probably should take to avoid things like memory leaks and to make sure that everything gets set up properly. Okay, so I've opened up NoteListView. Now, as you can see here, we have a reference to the adapter in the fragment. I do recommend taking that route and not putting a reference to the adapter in something like a view model. The reason why is that you don't really want to be putting classes which have a reference to like LayoutInflater and context and the view hierarchy in something like view model. So in this case, like I say, we're talking to it through the fragment here. Now, this is a really important step here. You can see I've overridden onDestroyView in the fragment. So what was happening is that after I got this thing all set up, I was getting a very strange memory leak, and I figured that out by using the tool Leak Canary, a very awesome tool. So I was trying to figure out what was going on here, and after a bit of Googling, I figured out that in certain cases, and again, this is just a feature of the fact that our adapter is tightly coupled to the view hierarchy and context and layout inflator and all that stuff. If you do not set the adapter property of the recycler view, and that's what this thing is here, to null, then chances are you may get a memory leak. I think it partly depends on how you have everything set up here, but in this particular case, if we want to have our adapter sort of separate from the fragment, I did need to include this detail here, otherwise I got a memory leak. Now, some of you may be wondering, and I went over this in the fragment tutorial in this series, but the way that we're able to just directly refer to these XML views, like so, is by using Kotlin synthetic properties up here. So go check the fragment tutorial out if you want an idea of how to do that. It basically completely eliminates find view by ID, which is really handy. Anyways, the only function, well, there's two functions we're going to look at next. So one of them is going to be setUpAdapter here. And so this is just a helper function that I've created so that we don't have just one giant onStart function. And when I scroll down to it, this is what we have here. So what we end up doing is we create a new instance of our NoteListEdapter, and we assign it to our adapter reference. The next thing that we do is we get a hook to the event property. Remember, that's our mutable LiveData object, and then we observe it so that when a click event happens in the adapter, in the recycler view, it's going to pop up here. Now, since our fragment has reference to the view model as well, what we'll do is through this lambda function here, that's where we will pass the particular event, and remember that contains the position of the item that was clicked. We pass that into the view model and then let the view model figure out what to do from there. Now, the last thing that we do after we get that set up is we assign our recycler view its adapter property to the adapter we just created. And now for the moment you've all been waiting for. How do we actually get our data into this particular RecyclerView adapter and RecyclerView? So if I scroll down to the observe view model function, and just note that I'm calling that after I set the adapter up. So just for people watching this, make sure you kind of don't mix these steps up here. We're setting it up first, and then we're asking the view model for the data. So if I scroll down to the particular observable, which is NoteList, so that's of course our list of notes, we observe it, and then when we receive a new note list, all we have to call is Adapter.submitList. Now don't worry about this function here, this is just like UI animation boilerplate stuff. This is seriously all we need to do to provide a new list to our adapter, and anytime we change the underlying list, it's going to pop up in here. We're going to call Adapter.submitList. The DiffUtil is going to figure out what to do from there, and then we are set. No more notify dataset change, notify item inserted, or confusion with creating a new list of data or all those kinds of things. Because for anyone who worked with RecyclerView before, it was actually kind of difficult and confusing how to, like, for example, update an entire list or change part of it or things like that. So all of that work that we did earlier did actually ultimately make our adapter simpler to work with. All right, that's basically it for today's tutorial. So if you learned something from that video or possibly even enjoyed it a little bit, then please do me a favor and hit the like button down below. Consider subscribing, and if you would like to learn about all the different tips and tricks in Kotlin that we used, do consider picking up my Kotlin course, link in the description box down below. It's going to show you not just how to use these different tips and tricks in terms of like Kotlin syntax and lambdas and those sorts of things, but I also cover all kinds of programming fundamentals for software architecture and just good quality program design. So once again, thank you very much for watching, and we'll see you in the next video. Peace out.